No, we're not. So you had the question out. All right. Which one? I think we'll do question 19 because I know how much you don't like. This is this is still exercise 6.7. But these are the extension 1 questions at the end because the integration involves integration by substitution. It's still motion and integration, but it's extension 1 because of the types of integration that you need to do. It's good that we do these because it's good revision of integration by substitution. So let's try question 19. It says acceleration, which is x double dot or a, equals t over the square root of t plus 2 meters per second per second. What do I write down now? I'll wait till you've written the question. 19. Acceleration equals t over the square root of t plus 2. It also says after 2 seconds, so when t equals 2, velocity is 1 1/3. Instead of writing 1 1/3, how would you like to write that? Good. Meters per second. And that's it. Use the substitution. U equals t plus 2 to find initial velocity. So using that, use that. And we want to find v when t equals 0. That's what we're doing. That's our question. So we've got our information. We're going to use the substitution u equals t plus 2. I know how much you guys love this. So, velocity, isn't it the integral of t over the square root of t plus 2 dt? Is that right? Yeah. X, v, a. We've got a and we're going back to v. We integrate. Okay, velocity is the integral of the acceleration. Let's go. Use the substitution. U equals t plus 2. Here's our little bit of working out on the side. Do you remember what to do? D what? Du dt is? Hello. Good. So dt, du equals dt. Now let's see how we're going. Let's see what we can substitute. Even though you don't think you have a substitution for t, you do. What does t equal? Yeah. So therefore t is u minus 2. Don't forget that one. People forgot that in the exam and they couldn't do the question. So t is u minus 2 over the square root of, what's t plus 2? And what's dt? Now, the other thing that people forgot to do is to break this up. The common denominator is root u. So it's u over the square root of u minus, break it up, 2 over the square root of u du, because there's no such thing as quotient rule for integration or anything like that. So you need to have them as 2 separate terms. So now what does that become to integrate? That's u to the what over u to the what? What's u on root u? It's root u. And because doesn't u equal square root of u squared? So therefore, doesn't u on square root of u equal square root of u squared on the square root of u, which is a square root of u, minus 2 over the square root of u, which is, keep going, integral of u to the what? U to the what? I don't want square roots, I need indices. Minus 2 what? U to the negative a half du. Jeez. Okay, so u over the square root of u is just square root of u, which is u to the half. And this is 2 times u to the negative a half. Let's integrate. Velocity is u to the, and don't mess this up, u to the what? 3 over 2 divided by 3 over 2. Well, we'll just divide it because a few people, did the wrong thing in the last exam. Minus 2, what's u to the negative a half plus 1? Over a half plus c. Next row, it's 2/3 u to the 3 over 2 minus 2 u to the half plus c. We probably, you can use your calculator with, and it is good. It's 2 times 2, which is 4. Thank you. Because it's 2 times 2 is 4. Good, now substitute. Luckily, when t is 0, we can't substitute because we got u's and not v's, so we need to substitute back. So u equals t plus 2. So let's change the u's to t plus 2's. Or, do you want to go when t is 0, u is 2? I suppose that's okay. Or I feel more comfortable replacing my u with t plus 2. You can do it either way. It's up to you. But do not go, you can't substitute. You can't substitute when t is 2. V is 4 on 3. You can't do it. We've got u. I don't mind. When t is 2, what's u? What do you want to do? Do you want to change this back to t's? I think we'll be safe. Change it back to t plus 2 minus 4 t plus 2 to the half plus c. Now, when t equals 2, v is 4 on 3. So let's put that in. 4 on 3 equals 2/3 times 4 to the power of 3 on 2 minus 4 times 4 to the half plus c. Now, girls, I prefer that you do this in your head. That's 2/3 times, what's 4 to the power of 3 on 2? Isn't it the square root of 4 cubed? 4 to the power of 3 on 2 is the square root of 4 cubed. What's 4 to the half? Square root of 4. Look, I'm just really worried that if you start pulling out your calculator, if you put it in incorrectly, you're gone. You lose a mark. You should be practicing this all the time. 4 to the power of 3 on 2 is the square root of 4 cubed. So it's 2/3 times what? Times 8, isn't it? Which is 16 on 3. And 4 times 2 is 8. So therefore now you could pull out your calculator if you want. It's 8 plus 4 on 3 minus 16 on 3. What's that? Negative 12 on 3. You don't even need your calculator. 8 minus 12 on 3. 8 minus 4. 4. Did you get 4? Good. It's up to you. If you're very calculator savvy, not going to make a mistake, use your calc. But if you're going to make a mistake, you're probably going to, and that's what you're going to tell me now, you're going to make a mistake anyway. So therefore, V equals 2 over 3. I'd like to write this as the square root of t plus 2 cubed, can I? Or no? Yes? That is that a no? Minus 4 t plus 2 to the half plus 4. There's your formula. Now you can answer the question. Find the initial velocity. Last part of the question. When t equals 0, you find v. Are we good? You get 2/3 2 to the 3 on 2 minus 4 times 2 to the half plus 4, and you can't even see. 2/3 times the square root of 2 cubed. You're going to need an exact value as well. Minus 4 root 2 plus 4. What do you get, girls? What's root? Are we good? What's root 2 cubed? Root 2 times root 2 times root 2. It's 2 root 2. So it's 2 times 2 root 2, which is 4 root 2 on 3 minus 4 root 2 plus 4. How are you going to make that look like something that... How do you make common denominator for me? Give me a common denominator of 3. What do you get? 4 root 2 minus 12 root 2. What's that? Yeah. You can actually just go negative 8 root 2 on 3 plus 4. That'll do. That's an exact answer. I'm sure. Can someone look it up? Do they want exact? Yeah. And simplify it exactly like that? So, yeah. Don't go, listen, after losing that mark in that exam for no exact values, I'm hoping that everyone's learnt their lesson. Not everyone, just some. Be totally correct, but the exact answer is correct. So if you feel like rounding, do your exact answer first and then give us a rounded answer. As long as an examiner can see that. So therefore, initial velocity, give us units. Meters per second. Nice. Why don't you girls try the substitution ones for the rest of the lesson, 18 and 20. Oh, goodness me. Exactly what we were going to start with in the first place. Look, when you see that result, cos squared x minus sine squared x, what does that equal? That's a double angle result. I will show you. I'll show you. This is 3 unit. This is what you're thinking of. Cos squared x plus sine squared x is 1. That's the 2 unit result. The 3 unit one, I'll go. No, I'll show you the 3 unit. Here we go. And it's stuck. Here we go. Keep going. Where are we? Where's trig on this? Where's the trig? Where's sine squared plus cos squared is 1? No, I'm on to extension. That's not the one. I just want to show you the... Where's the trig? They don't have it. They don't have sine squared plus cos squared is 1. Oh, I thought they would have. Okay, here we go. Where? Don't tell me there's no double angle. Nah, there's no... Well, that is your double angle result. See it? Okay, girls. There's your double angle result. Cos of 2, like if the, what symbol is that one? Phi equals theta, then cos, that's, if they're both theta, cos 2 theta is cos squared theta minus sine squared theta. The double angle result is in there without you knowing it. Okay? So, back over here, cos squared x minus sine squared x is the double angle result, which is cos 2x. So therefore, we can say that that is cos of 2 times, that's your x in this, 2 bracket t plus pi on 4, which is cos, come on, how do I write that? 2 times t is 2t plus 2 pi on 4 is 2t plus 2 pi on 4 is 2t plus pi on 2. That's what acceleration is. So, I'll get the question back up when I find it. Like that. That's like integrating something like this. So we've got acceleration is like cos of 2x plus, you know, alpha or something, like a constant. Okay? It's like doing cos of AB plus C. We can integrate that, can't we? If you look at your 2 unit sheet, all right? There it is. Having a look. See? Integral of cos AX plus B. Can you see? We can do that. Because it's 2, so we can do that. Cos of AX plus B is 1 on A. So I'll just write it. Cos of AX plus B, the integral of cos AX plus B equals 1 on A sine AX plus B plus C. So I'm just putting that on my sheet there because you'll have the formula sheet. you can integrate something of the form cos ax plus b. You'll get 1 on a sine of ax plus b plus c. It is in that form. Now, so therefore, what do we get? Velocity or x dot. Yeah, I'm continuing. I just had to do the side thing of changing that. Which is integral of cos 2t plus pi on 2 dt. What do you get? 1 on 2 sine 2t plus pi on 2 plus c. That's what v is. Initially, the weight is at rest, at the origin. I did not write this before, but initially, when t equals 0, we know two things. Initially, the particle is at rest and at the origin. So we've got when t is 0, v is 0. When t is 0, x is 0. Okay, do you know what to do now? Off you go. X. Don't we know that so we know that cos 2x is 2 cos squared x minus 1. So therefore cos squared x is cos of 2x plus 1 over 2. But for those that were thinking of doing it this way, we know that cos 2x is also 1 minus 2 sine squared x. So therefore sine squared x is 1 minus cos 2x over 2. Now, if I do now, just showing you, cos squared x minus sine squared x, which is what we had, it's cos, just watch, cos of 2x on 2 plus a half minus all of that, minus bracket a half minus cos 2x on 2. What do you get? The halves cancel, and what do you get? You get cos of 2x on 2 plus cos of, I'll just show you, 2x on 2, which is a half cos 2x plus a half cos 2x, which is just one lot of cos 2x, which is what we were doing. Can you see why would you do this? So be very careful. If you were going to go with this method, doing integral of cos squared, integral of sine squared, you would have just been doing the double angle result. Look, from there to there, that's the double angle result. Do you see it? So please, if you ever see cos squared minus sine squared integrating, you've got to think double angle result, not integral of cos squared, integral of sine squared. Got it? Because I've got cos 2x on 2, I broke these up, that over that plus that over that. Because that's cos 2x on 2 is a half of cos 2x plus a half of cos 2x. What's half x plus half x? 1x. I've got 2. Yeah, it's because it's 2 cos 2x on 2. Do you see that? Which is cos 2x. So therefore, much easier to see that you've got the double angle result than I'm integrating cos squared x sine squared x. So we're not going to do it that way. That's too long. Because it's cos squared x is all of that minus whatever sine squared x is. No, that is you. What you've got to do with the initial question is simplify it. If you try and integrate that, oh yeah, we're still not finished. I'm just showing why you use the double formula as opposed to doing this, combining them gives you the double angle result anyway. So cos squared x minus sine squared x is cos 2x. We've got cos squared that minus sine squared that is cos 2 of that. Pretend that that's x and that's x. Got it? Cos squared of something minus sine squared of something is cos of 2 times that something. Got it? So that's what we've done. We don't need all this, but I wanted to show it to you anyway. So if you're ever just integrating cos squared x on its own, go for it. Do this. But not if you're doing cos squared minus sine squared, or even cos squared plus sine squared would be 1 anyway. You wouldn't be doing it. So please know your double angle results. Don't think because you've got a formula sheet you don't have to learn anything. You still do. Okay, can I get rid of this now? That's a minus there. I know it's a big minus. Okay, I just didn't have room. So let's go back up here. So what's the question? I don't even know what the question is anymore. So find the velocity, but no, we need to work out what c is. So what do we substitute? When, we need to work out what c is. When t is 0, v is 0, 0 is a half. Don't think this is just automatically 0. Sine of what? Good. Plus c. To know what sine pi on 2 is, you should be doing the sketch. What's sine pi on 2? Sine 90. If you don't know the sketch, you put it in your calc. Sine 90, 1. So 0 equals a half times 1 plus c. So what's c? Negative a half. Guys, see, this is where you go pick it up and take it over with your pen. You don't just write the answer. Please, it's those little mistakes that you don't want to lose a mark. It's such a shame because you know what you're doing. A lot of people make the silly little mistakes, and that's by not making things, I suppose, kinesthetic, like moving them, physically moving it to the other side will help you stop doing that. All right? Pick that up and take it over. So therefore, v equals a half sine of 2t plus pi on 2 minus a half. Hallelujah. We have a formula. Next, find the velocity. When? Now we're up to part A. Now we can actually answer the question. I mean, that all is part A, but now we're actually answering the question. Find the velocity after pi on 2. We good? Find v when t equals pi on 2, and you get v is a half sine 2 pi on 2 is what? Pi plus pi on 2. What's pi plus pi on 2? It's 1 plus a half. Sine of 3 pi on 2 minus a half. Here's your graph. 3 pi on 2 is here. See, that's 2 pi. That's pi. So 3 pi on 2 is down here. What is it? Negative 1. So it's a half times negative 1 minus a half. What do you get? Negative a half minus a half. Negative 1. So therefore, the velocity equals 1 meter or centimeter? Centimeter per second. 1 centimeter per second to the left. Actually, not to the left, going down. Why don't you just say in the negative direction? If you don't know if it's left or down, just go in the negative direction. Well, we're thinking the weight's on the end of a spring. I don't think it's sideways one. Just go 1 centimeter per second in the negative direction. Part B. Geez, another one. Find the displacement after pi on 4. You know what you're doing? What do? X is the integral of v. X is the integral. This is the nice, oh no, there's your v, this one. Integral of, oh geez, I think we should take the half out. Oh, what a pain. What do you want to do? You've got to integrate this. You good? Are you going to take the half out, or are you going to put them over 2? Or just leave it? All right, we go sine 2t plus pi on 2 over 2 minus a half dt. Have fun. Jeez. What do you get? Integrate sine. What do you get? Negative cos. That's right. So you get negative cos 2t plus pi on 2 divided by, there's that 2, but times, you've got to put a half. Now, you know where that half goes? It goes down there. That goes -1/2. That's the half. Divide by 2 ends up down there too. If you don't believe me, you go divide by 2, which is times a half. So there's the half, and that's that 2 down there. Minus what? Minus t on 2. Get rid of that. So that's minus t on 2 plus c. Jeez. What do we sub? Wait, I'm just one sec. So we get, you didn't change it to cos, and negative cos as well. It's negative cos 2t plus pi on 2 over 4 minus t on 2 plus c. Now what do we sub? When t is 0, what was x? Initially, the particle is at rest at the origin. So we get 0 is negative cos. If you put t as 0, you get pi on 2 over 4 minus 0 plus c. Cos curve. What's cos of pi on 2? Well, that's 2 pi, and that's pi. What's pi on 2? Cos pi on 2? Cos 90? What's cos 90? Yay! 0 is 0 plus c. C is 0, thank goodness. Cos of 90 is 0. There's the cos curve. No. It's 2t plus pi on 2. You never change what's in there. You get -1 on 2 cos 2t plus pi on 2. It never was pi on 4. No, it's 2 bracket 2t times. Therefore, x is negative cos 2t plus pi on 2 over 4 minus t on 2. Sub t is pi on 4. Therefore, it doesn't matter. X is negative cos 2 pi on 4 is what? Pi on 2 plus pi on 2 over 4 minus pi over 4 divided by 2 is pi on 8, which is negative cos. What's pi on 2 plus pi on 2? Over 4 minus pi on 8. What's cos of pi? -1. -1 on 4 minus pi on 8. Oh, miss, it's being recorded anyway. 1/4 minus pi on 8. Goodness me. Meters. Centimeters? Centimeters. Jeez. So we get -1/2 equals, the V equation is 1/2 sine 2t plus pi on 2 minus 1/2. So that's good, because that's the equation for V. The -1/2s go, so we get 0, or we get 1/2 sine 2t plus pi on 2 is 0, don't we? Which means that sine of 2t plus pi on 2 is also 0, because if you times by 2, sine of what is 0? Find the times. Well, they want a general solution or a pattern. So, you know how, no, that's okay, girls. So, here's my sine curve. When is sine 0? So, therefore, you've got, I think we need a general, look, so therefore, 2t plus pi on 2 will be equal to all of these things. 0, pi, 2 pi, 3 pi, etc. Do you get that? Sine of 0 is 0. Sine of pi is 0. Sine of 2 pi is 0. So therefore, the 2t plus pi on 2 will be 0, pi, 2 pi, 3 pi. What do I do now? Minus pi on 2 from everything. So you get -pi on 2, pi minus pi on 2 is pi on 2. 2 minus a half is 3 pi on 2. 3 pi minus pi on 2 is 3 minus a half. It's 2 and a half, which is 5 pi on 2. You can see what the next one is, can't you? 7 pi on 2. But now we're dividing by 2. So what do you get? Yeah, negative pi on 4. But girls, which one of those do I have to eliminate? Good. So equals just the positive ones. Pi on 4, 3 pi on 4, 5 pi on 4, etc. As t is greater than 0. Okay? So the times at which the weight has that velocity is pi on 4, 3 pi on 4, 5 pi on 4, comma, dot, 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 7 pi on 4, etc. General solution would be what? Wouldn't it just be pi n plus pi on 4? As a general solution, it's, you know, the one for sine, isn't it pi n plus, oh, the negative one. Oh, goodness. But the alpha 0. The alpha 0, because sine 0 is 0, so that's all gone. It's just pi, but then that's what 2t plus pi on 2 is. Do you know what I mean? So if you want to do it as general solution, is 2t plus pi on 2 is pi n plus that times 0, which is just 2t plus pi on 2 equals pi n. No, it's plus. Plus negative 1 to the n times 0. So therefore, t is, as a general solution, pi n minus pi on 2, then divided by 2. 2t is that. You okay with that? Therefore, t is pi n on 2 minus pi on 4. That's as a general solution. I like this. I think you get the marks for that. No problem. You're showing the pattern by putting the comma, dot, dot, dot. All right? So there's that. Because that's what 2t plus pi on 2 is pi n plus negative 1 to the power of n times 0. So 2t plus pi on 2 is pi n. 2t is pi n minus pi on 2. And then you're dividing both of these by 2 up there. That's your general solution. And if you substitute n is 0, you get negative pi on 4. If you substitute n is 1, you get what we were getting here. Same. All right? That's it. Done.